Ashok here, and this video is a part 2 of Python Essentials for Data Science. We have covered till conditional statement. It's actually one statement, if component statement, in the last video. Now we're going to look at several data objects, which are Python data objects, which are very relevant for data science. Let's start with lists. And in this video, I will cover lists, tuple, strings, and dictionaries, and yeah, that is it. Well, we'll also cover the sets. We will also cover functions and loops for loop. Okay, I will change this into Markdown. Save it. Okay, no, that doesn't look good. Python data objects and others as well. Okay, that's better. We will start with lists. Okay, I'll put that in the second section. Lists. So lists are special objects. If you want to say in one sentence, Python lists are very flexible and can hold completely heterogeneous yes, okay, I guess it's wrong. I should go 0 over there. Okay. Heterogeneous data. They can be manipulated very efficiently. Okay, so what I mean by that? Let's say I have a small, let's just declare my list. The way you define a list in Python is by using square brackets. Square brackets, and you can write down the elements inside the list just by separating by a comma. All right, I can say 3, 5.4, which is a float. 3 is an integer. I can put a string. I want to be a data scientist. Okay, this is my list. I'm going to just write it down again so that I can display it. As you can see, a list can store completely heterogeneous elements. Like I have an integer, I have a float, I can also put a boolean. Let's say true, that's a boolean. All right, a boolean and a string. And it's very useful. So let's define more meaningful lists. Say family, or I would say my family. Okay, and I can define, how you define a list by just using a square brackets. Between the square brackets, you can define. I'm defining a list which is completely a string list. I would say mom, which is a string, so I have put it in a quotes, comma for the second element, dad, and me. Very sweet small family. I would say my family, and here we go. So it just stored mom, dad, and me. If you want to retrieve an element from the list, I can retrieve by simply using the selector operator, which is again a square bracket, and I can say 1, or if I want to retrieve myself, I'll put it 2, and it should be telling me me. So this 2 is an index. Index always starts from 0. So in my family list, mom has a 0 index, 2 has like dad has a 2 index, and sorry, mom has a 0 index, dad has 1 as an index, and me object or me element has 2 as an index. So if I put a 0 here, I should be getting mom. Okay, pretty simple. It is just like an arrays from other languages, and in Python this is very effective. Okay, and there are a lot of functions within lists. We're going to explore a few of them to understand how it works. Let's say I want to extend my family. I want to add more elements. Okay, I want to add a few more people to my family. The command for that is pretty straightforward. It's extend, and it's a function. So we open and close a parenthesis, and inside that we can pass on another list which contains many other elements. For example, my wife, I would put my brother first, my brother, okay, and my wife, and my aunt, basically in-law mother. And let's see my family, how it looks like now. So now I have 6 elements: mom, dad, me, bro, wife, and aunt. Okay. If you want to just add one element at end of the list, we have another command or another function for it, and that is append. Append literally means add at the end. Append. All right. And I don't have to pass on a list because it's a single element. I can simply write down that element. I can just write on the element. So I would say daughter. Okay. I can print my family now. So I should have 7 elements: mom, dad, me, bro, wife, aunt, and my daughter. Pretty good. Okay, so we learned how to initiate a list and how to extend a list with multiple elements. So this is basically used when you want to add multiple elements to the list. And if you want to add a single element at end of the list, we can use append, single element. This is add multiple elements. This is add single element at the end of this. Okay. Very nice. There are other commands which are also very useful. For example, count. That's used for knowing how many times a particular element, because list can have duplicates, right? It can have duplicates. Let me just add myself one more time. Me appearing twice in the family. I will say append and add me. So my family has 7 members and me repeated twice. So here is me and here is me again. I want to count how many times I'm appearing in my family. Okay, so family, the function for it is simply count, and I pass on the element value, which is me, and it will return 2, which means that the me is appearing twice in my list. If I pass on, let's say dad, which is only 1, I am expecting 1 to be coming over here. Okay, that's the count function. All right, and extend, count, that's pretty much about adding and counting. Let's talk about removing. If I want to remove an element from the list, the command for that the command for that is dot remove. Very user friendly. I want to remove myself from the family. Okay, just like that. And let me see, am I still there? Well, technically, the first instance of my appearance, me, here has been removed. See, after dad, that should be me. But the second instance is still there, which means that the remove function only removes the first instance of that element. Okay, if I do it one more time, all right, if I remove it one more time, the second element will be also removed, but that's obvious. Okay, and that's pretty good. And if I want to remove but not remove. I just want to pop. There's another command called as pop, which returns me the element and removes me. For example, I want to pop myself, or I want to pop my brother out of my family for some reasons. The function for it is simply pop. I would say pop bro it, or sorry, I should be passing on the element which I want to pop. That's normal in pop. So brother is actually third element, which is 0, 1, 2. I would pop 2, and here we go. I got a brother. That's very nice, but my brother has been removed from my family because that's how the pop function works. See, I don't have a brother anymore in my family. All right. So whether pop function pops up and gives a value and removes from the list. It's like taking out from the list, taking out from the basket. Okay. All right, so that's good enough, and you can play around. There are a lot of functions in the list which you can explore by simply typing tab, and you see a list of function: append, clear, copy, context, and index, insert. Insert works just like remove. You can put an index and then pass on an element. It will insert at that point, at that, wherever position you want to insert. Reverse the list, sort it. You can do all these things. You can experiment, and it's pretty easy to run. So I'll leave it here for your experiments, and you just type in that list name and press tab. You'll get a list of commands. Every function here is pretty self-explanatory, so you can just use it, and if you have any further doubts, you can just go ahead and type in Python lists, and you get a first link from Python list tutorial point. Just go for the base one. There are a lot of other helping sites, but I would rather normally go for the python.org list and go into the documentation. But you have a very nice documentation: append, extend, insert, and this is good enough for you to understand. Let's move on to the next element in Python, which is tuples. Tuples. All right, so tuples. What is tuples? Tuples very much look like your list. A tuple is a sequence of Python objects, and very important thing in tuple is it is immutable. Means you cannot change it. Once you assign it, then you cannot change it. In list, you can add, edit, append, modify. Even I can replace. For example, see, this is my family. If I want to replace my aunt with my uncle for whatsoever reason, my aunt position is 4. I can simply say 4 is like 0, 1, 2, 3, and then is equal to uncle. All right. And if I look at my family, the aunt is being directly replaced by uncle. It's very effective and very easy to manage and play with the list and modify the list. Tuples, on the other hand, the purpose itself is it's immutable. I mean, you cannot change it. Once you assign it, you cannot change it. Why do you have the tuples? Well, there are many tuple applications. For example, a simple logging. Let's say you are doing some sort of application for let's say telecom operators, and every call happens in a telecom system, telecommunication. It's been logged from whom, to whom, and what's the time, how much duration, a lot of things. And these are logs. You don't have any, typically these logs shouldn't be changed. There should not be any provision to change either through programmatically or manually to change this, right? It should be, once it is logged, it should not be changed. For those kinds of entries and information, use tuples. Tuples by nature is immutable, which means you cannot change it. And there are a lot of application tuples, especially when you don't want to change a record by any means, you can actually use a tuple. Okay? Let's define a tuple, my tuple. Just quick. Just like your list, where you initiate using square brackets, tuples are initiated using parentheses. Open a parenthesis and just keep writing. Tuples are also heterogeneous, which means you can have a number, you can have a float, you can have a string. Hey, hello, hello. etc. And here we go. We have just defined a tuple which is 1, 3.4 and hello. Okay, well, let's try tweaking this tuple. Like let's see that can I access the second element, which is index is 1, and put something else. It's 3.4. I want to say it's 4.3. It will simply say that tuple object does not support item assignment. Basically means you cannot change it. And that's the whole point. Tuples cannot be changed. In some purposes, we need to define certain things which you cannot actually change. Okay. If you want to know the length of the tuple, even the same command works pretty good with list. Simply len length, and I can say my tuple, and here it will give you 3. It's 3 numbers in the tuple. Okay. Tuples can also be declared in slightly different way. One is like by directly opening and closing a parenthesis and you put in the elements inside it. But you can also define tuple, my tuple 2 for example. I can define it using a small function called as tuple itself and pass on a list. Remember, when you open and close square brackets, you are actually passing on a list. I'll pass on something like 5, 6, hey, and true because it's heterogeneous, and my tuple 2. This is very similar as this, but in this case you are passing on a list and using a function called tuple. It's kind of like typecasting. If you see the force typecasting we have did in the first video, the part 1 of the Python essentials, and it's very similar. Here using tuple. There are 2 ways of declaring it. One is directly by using parenthesis or using a function tuple and passing on a list. So this is a list because it has an open and square brackets. All right, and pretty much you can't really do anything with tuple. You just define it and use it. So we don't have to. The only thing is we can retrieve the elements. So retrieve the elements is pretty much very similar to your list. I can pass on, let's say 2. So I'm expecting, see this 2 is this one, 0, 1, 2. I'm expecting an hello over here. And we get hello. So retrieval is pretty much like list. The only difference is immutable. You cannot change it. You cannot assign it. You cannot modify it. You cannot remove it. You cannot add it. Once you declare a tuple, it stays tuple, right, without change. All right, so I leave it for you to experiment other examples and other functions within tuple. Other functions can be accessed just like I told before. You put a dot and press a tab. You will get only 2 functions, count and index, understandably because you cannot change it. Count will give you a count. Index will give you basically where is this element. Okay, you can just look into the documentation and take this forward. Let's move on to the next data type, which is a very popular one, strings. I'll change it to markdown. Strings. Okay, strings. Well, strings is something which pretty much everyone knows, and I can declare a string like my goal is my string variable, and I can say I want to be a data scientist. Pretty good. And I would simply run it, and that's a string. Okay, and strings can be accessed in many manners. String is actually a collection of individual characters. So if I say my goal and a selector brackets, which is a selector square brackets, if I give 10 for example, I don't know what is the 10th element, 1, 2, space is considered as an element or a character, 3, 4, 5, 6, 7, 8, 9, 10, not good. I am getting a space. So let me put as 11. So I will get a B. So I'm expecting a B here, okay? Oh, so did I count something wrong? 1, 2, is it 2 space or 1 space? No, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Yeah, of course. When you say 11, it starts from 0, so it will return you the 12th element. E is correct. If I give 10, then I will get a B, of course. All right, just to show you, you can retrieve. If you want to retrieve a range of elements or a substring, as we call, we will use a selector function. So the slicing function. So what is the slicing function? If I say just 10, then I'm getting the B. But if you say from 10 and you put a colon, the colon, two dots, that's colon. Colon is a slicing operator. What it does, it's basically takes the starting and ending from on the both sides. If I say 10 and then till 18, I don't know what is the 18th character. So it's going to display me everything from 10th. Basically, when you say 10, it's 11th element because it starts from 0, from 11th till 19th. Okay, let's execute it. It's BA dat. Okay, I'll put a 19. BA data. Okay, so that's slicing operator. So it considers from 10 till 19. Okay. If you don't put anything in the second end, so I don't just put anything, I just remove it. I just say 10 and a colon. It will assume till the end. So it will take everything from 10. So if I just do it, be a data scientist. Okay. And if I didn't specify the beginning one, like the from index, and I simply say 9, so it will assume from the beginning. So this should be I want to. So nothing colon 9 will give you everything from the beginning till the 9th. 10 colon and again a missing element, which basically assumes to be the end. So it gives a be a data scientist. So this operator is very, very, very helpful when you're doing selecting the data in data science analysis, especially in data frame, which you're going to cover in the next video, pandas video. That's the slicing operator is very effective, and we use it all the time. There are also other ways of doing things. If you mention a negative index, I would say -1. All right, -1 means counting from the reverse. So -1 gives me T because it's counting from that end. Okay, T. So it's giving me T because it's counting from this end. You can think about all the things, all the combinations using this and play with it and get thorough. If I say -1 to -15, so it's going to take from -1 to -15. From this side, 15 characters. I don't know what we get, but just display it. Nothing came in. Okay, -1. Oh, sorry, -1. And then I would say this is beginning is -1. I have to say -15 because that's a beginning till -1, and then you'll get something. Okay, great, wonderful. And that's the string and a couple of ways to retrieve a substring, which is very essential because when you're data cleaning or modifying, manipulating data, string operators and the slicing operators comes very handy. Okay. All right. So let's move on to the next one called dictionaries. Dictionaries. Okay. What are they? Just remember your dictionary where you look at for a meaning. And how do you do it? You simply look for, let's say I'm looking for a meaning of what is an science. Okay. And you'll find some study of, field of, or something like kind of thing. So this is a key or a word you're looking at, and this is the value or basically meaning of it. In the similar manner, Python has its own dictionary. So when I say mydict and is equal to, dictionaries are always opened or initiated using what do you call this, curly braces. The curly braces, you have kind of curly, and inside that you can define key pairs. So what is key pair? I can say my name is Ashok. So this is how we define it. So this name is a key and this is a value. Okay, and I can say my age is again a key, so 42, and my job is a key, and I say data scientist, etc. Okay, and this is my dictionary. And this is how the dictionaries are created. If I print it, you get it in a right order. Okay, name Ashok, age 42, job data scientist. Okay, if I want to retrieve a particular element, I can pass on the key to get the value. So what I mean, I can say dict and pass on the key. What's my name? I'm expecting Ashok over here. What's my age? From the dictionary, it's 42. And what's my job? It's data scientist. So this is how the dictionary works. Dictionaries can be also defined in another method, and that is you can pass on a function, pass on a list to a function called as dict. Okay, and you don't need a curly brace. You can pass on a list. Okay. All right. So I defined. I I used dict function and then passed on a list. When you're doing it this manner, you can also have a different notation. Rather than doing this, I can simply use this notation. I sometimes find this as more readable. Okay, I don't need this. And job. Okay, see, this is slightly not readable. I mean, it's my opinion, of course. So there are like this, the key and the value looks exactly same. Both are in parentheses and there is a colon in between. But here, I can see the name as a key separately and the value in, if it is a string, it's in the quotation. If it's an integer, it is like without quotation, whatever. This notation is much clearer. I somehow like this way of doing it, but it's just a matter of what you like better. And this does exactly the same job as the other one. Okay, my apologies. Okay, I don't need actually this list function. That's right. I can directly pass it on. Okay, great. So this notation or the this notation is up to how you use it. Okay, and that's dictionary. And the last topic of this session is sets. Well, we also cover function and loops very shortly. So let's complete with the sets. Hope you remember the sets from your schooling days. Sets, union, union, intersection. Most of us remember it. Intersection. If you don't, just take a quick search for it. So in Python, I'll just write down one sentence. What is a set? Okay, a set contains an unordered, because order does not matter in a set, collection of unique and immutable objects. When you say unique, it means that you can't have duplicates in a set. Okay. How do you define a set? The set definition is very similar to your dictionary definition in terms of use curly brackets, but you don't give a key pass. You just pass on elements. All right. For example, I'm declaring a set which is, let's say I'll give a different name, right? Same like that, mom, dad, me, and me again, okay? Observe carefully, here I'm using double quotation and here I'm using single quotation, doesn't matter. Right? Even if you use double quotation or single quotation, Python is going to treat it as a string. But just make sure that when you use double quotation to open a particular string, close it with the same double quotation. Right? Jupyter automatically does it. So when you just press in one quotation, it automatically opens the other one. So the chances that you go wrong is minimal, right? So this is my set, but when you display this one, you don't find two me's here. See, I have given two me's, but being a set, it cannot have a duplicate. It only shows one, which means that basically two is combined to one. So it removes the duplicate by nature. That's one of the property of your search. So let's define some more meaningful sets. Language, or programming language. How do you spell the language? I always have difficulty with spellings. I don't know why. Language, right? Language. All right. Okay. Languages. And I'm going to say programming languages. I would say Cobra and Java and PHP. Let's do some R and Python. Let's know we are actually data science guys, right? So R and Python. Pretty cool. And I'm going to define another set which I call it as snakes. Snakes, real snakes. And I don't know what kind of snakes. Okay, yeah, I don't know if there is a snake called this should be here, isn't it? Yeah. My apologies. Cobra and rattlesnake. Rattlesnake. How do you use rattlesnake? I would use. Okay, viper and Python. Python is a snake as well, right? Okay, great. I have defined two sets with 3 elements each. Okay. When you say union, it combines both the sets elements, and if there are any duplicates, it removes it. So when I union languages and dot union, you can put a dot and press a tab. You will see all the things you can do with the set. I'm going to select union here, and I pass on snakes. Okay. So what you see here is it combined both the sets because that's what the union means. But the Python is being repeated twice, so it has just removed the duplicate. So you only have 5 elements in the place of 6 elements. Okay, and if you do intersection, as you can expect, intersection only returns the elements which is appearing in both the sets. So you expect only Python. Okay, that's pretty much about sets. You can go into more complex sets definition, but this is good enough on the essential level. There are only 2 topics to cover in this video. First one is functions. Okay. And again, if you are from programming background, you know what is function. Function is a chunk of code which is written once and used many times. If you have a certain code which you would like to write it once and use it many times, it's better you go with the function. So I'm going to just define a quick function. The way you define the function in Python is using a keyword called def. Def means definition. And then the function name. I'm defining a function is even. Okay, even odd numbers. And I'll take an argument in it. Okay, and I put a colon. So this is the way you define a function. Definition is a keyword called def and the function name. And then you open and close a parenthesis. If there is any argument, you give a x or something to actually take the argument in. I want to test a number, whether it's even or an odd, an integer. All right. So I have given an x here. Here I say if x modulus 2, which means, if the modulus is 0, which means it's perfectly dividing. If it is true, then it's an even. Okay. I can say return true. Okay, that's even number because the function says is even. Else, I will simply return false. That's all. That's a simple function. But whenever I want to check a particular number, whether it's even or odd, I don't have to write the entire code. I can simply say is even. That's how you call it. Let's pass on some 5. Okay. Let's see what it returns. It says false. No, 5 is not an even. Put a 6 here. It says true. Fantastic. So we have written a piece of code with a definition and a function name taking an argument. When you're using this function and pass on a 6 value, the value actually captured in the argument variable x and we are doing a simple logic here, x modulus 2. Any even number which is perfectly divided by 2 is called as even. If it is divided by 2, the modulus will be 0. There won't be any remainder. If that is the case, you return a true. If not, it's an odd number, so you return a false. That's pretty much a very simple function, and that can be extended to the extent you want based on your programming requirements. And the last one we're going to discuss is loops. In Python, there are quite some loops, but we predominantly use for loop. Okay, so what is a for loop? Let's define a quick list called fruits, and that's apple, banana, and what else? Pineapple. Oh, it's apple again. That's okay. I like pineapple. And a mango. Okay, and an orange. Okay. I want to loop through the entire list and do something. Okay, and I want to loop through each and every one and display, the apple and the length. How big is the apple? I mean, what is the length of the apple? I can write a simple for command like for, and I give a simple holder called as fruit maybe. And then in fruits, so fruits is the list, and you put a colon, and when you put a colon come down, you observe that there is an automatic indentation. Same also in the function. So if you don't have this indentation, Python will throw you an error because it doesn't understand where the function is actually ending and what is the block. Even in the if condition, you have another indentation coming automatically. In a similar manner, when you press enter, you have an indentation, a space, and then the cursor is blinking. I will print this saying fruit, which will print the element in the fruit. So this will keep on repeating. So the first iteration or the first cycle, apple will come here. Second cycle, the second value, banana will come here, and so on and so forth. I would say print and fruit, then array has, and I would again say length. So I want to say how many characters it is, length of fruit, and again I'll say fruit has so many characters. Just to make it nice. When I run this command, oh, there's some problem. Must be integer, not a string. What is that? Oh, has some problem here. Oh, okay. So this is an integer, so I have to convert it into a string. Otherwise, you're adding integer to a string. It's just not good. Okay. Apple has 5 characters. Banana has 6 characters. Pineapple has 9 characters. Mango has 5 characters. Orange has 6 characters. This is a simple demonstration of a function, a loop, which can go through each and every element with just one single statement. Look at how simple it is. It's a fruit in fruits. Many advanced languages also have the same, but Python has, it's really easy language. I love it for its simplicity, and I love Jupyter because you can write the documentation and also run the code in the same sheet. Okay, this completes our Python essentials for data science. And the further videos, advanced videos, are more into Python packages such as NumPy, Pandas, scikit-learn, matplotlib, and we also cover SciPy, scientific Python. We have Seaborn, etc. So in further tutorials, I will explore each of these Python data science packages in one video as we go. Hope this tutorial is useful, and thanks for watching. Don't forget to subscribe so that you get an update when I upload a video. Thank you.